According to the National Electrical Code, specifically Article 314.20 A2, B. Electrical boxes must be securely fastened to structural members of the building. Installing a mud box directly on block walls does not meet this requirement, as block walls are not typically considered structural members. Also, NEC Article 314.20 B requires that electrical boxes be accessible after installation. Using a mud box concealed behind drywall makes it difficult to access the box for maintenance or repairs. Installing a mud box in this way is generally not considered standard practice in the electrical industry. Firstly, structural integrity is a concern. Mud boxes are not designed to support the weight of electrical devices and wiring, which could lead to structural damage. Secondly, fire safety is a concern. Concealing electrical boxes behind drywall can increase the risk of fire by trapping heat and smoke. Thirdly, accessibility is a major concern. Accessing electrical boxes for maintenance or repairs can be difficult or impossible after they are concealed. A recommended practice includes these steps. Firstly, install a metal electrical box directly on the block wall using appropriate anchors or masonry nails. Secondly, run polyvinyl chloride or PVC conduit or electrical metallic tubing or EMT from the box to the junction box above the suspended ceiling. Thirdly, install a junction box above the suspended ceiling and connect the branch circuits to the junction box. And fourthly, provide proper grounding according to NEC requirements. It's important to always follow the National Electrical Code and local codes to ensure the safety and compliance of electrical installations. When installing electrical boxes, ensure they are securely fastened to structural members, remain accessible, and provide proper grounding for all circuits. Using appropriate hardware and methods for securing boxes to block walls is crucial for maintaining electrical safety and adhering to code requirements. Always consult with a qualified electrician if you have any questions or concerns about electrical installations. Proper grounding is a critical safety measure in electrical systems. It provides a path for fault current to flow back to the source, tripping a circuit breaker or fuse and preventing electrical shock hazards. According to the NEC, all electrical boxes must be properly grounded. This typically involves connecting a grounding conductor, often a bare or green wire, to the grounding terminal inside the box. The grounding conductor is then connected to the equipment grounding conductor of the branch circuit, creating a continuous grounding path back to the service panel. When using metal conduit, the conduit itself can serve as the equipment grounding conductor, provided that it is properly installed and all connections are tight. However, when using non-metallic conduit, such as PVC, a separate equipment grounding conductor must be installed within the conduit. In addition to grounding the electrical boxes, it is also important to ground all electrical devices that are connected to the branch circuits. This includes receptacles, switches, and lighting fixtures. The grounding conductor from the device is connected to the grounding terminal on the electrical box, ensuring that all metal parts of the device are properly grounded. Regular inspection and testing of grounding systems is essential to ensure their effectiveness. Grounding conductors should be checked for continuity and proper connection. Ground resistance measurements can also be taken to verify that the grounding system is providing a low impedance path for fault current. Any deficiencies in the grounding system should be corrected immediately to prevent electrical shock hazards. By following these grounding requirements, you can create a safe and reliable electrical system that protects people and property from electrical hazards. It's always important to consult with a qualified electrician if you have any questions or concerns about grounding electrical systems. Proper selection and installation of electrical boxes are critical for ensuring the safety and compliance of electrical installations. Electrical boxes are designed to provide a safe enclosure for electrical connections, protect wiring from damage, and provide a means for mounting electrical devices. The NEC specifies the types of electrical boxes that are permitted for various applications, as well as the requirements for their installation. Electrical boxes are typically made of metal or non-metallic materials, such as plastic. Metal boxes are generally stronger and more durable than non-metallic boxes, and they provide better protection against fire and physical damage. However, non-metallic boxes are less expensive and easier to install, and they are suitable for many applications. The size of the electrical box must be appropriate for the number and size of conductors that will be installed in the box. The NEC provides guidelines for calculating the minimum box volume required for different wiring configurations. It's important to choose a box that is large enough to accommodate all of the conductors and devices without overcrowding. Electrical boxes must be securely fastened to structural members of the building. This can be accomplished using various methods, such as screws, nails, or clamps. The fastening method must be appropriate for the type of wall or ceiling construction. Electrical boxes must be accessible after installation. This means that they cannot be concealed behind walls or ceilings without providing access panels. Access panels should be large enough to allow for easy access to the electrical box for maintenance or repairs. When installing electrical boxes, it's important to follow all applicable NEC requirements. This includes proper grounding, wire connections, and box fill calculations. By following these requirements, you can ensure that your electrical installations are safe and compliant. Conduit systems are used to protect electrical wiring from physical damage, moisture, and other environmental factors. The NEC specifies the types of conduit that are permitted for various applications, as well as the requirements for their installation. There are several types of conduit commonly used in electrical installations, including rigid metal conduit, intermediate metal conduit, electrical metallic tubing, flexible metal conduit, and non-metallic conduit. Each type of conduit has its own advantages and disadvantages, and the choice of conduit will depend on the specific application. Rigid metal conduit is the strongest and most durable type of conduit, and it is typically used in applications where the wiring is exposed to severe physical damage. Intermediate metal conduit is similar to rigid metal conduit, but it is lighter in weight and easier to install. Electrical metallic tubing is a thin-walled conduit that is commonly used in residential and commercial buildings. Flexible metal conduit is used in applications where flexibility is required, such as connecting to motors or other equipment that vibrates. Non-metallic conduit is made of plastic and is used in applications where corrosion resistance is important. The NEC specifies the minimum size of conduit that is permitted for different wiring configurations. The size of the conduit must be large enough to accommodate all of the conductors without overcrowding. Conduit must be properly supported and secured to structural members of the building. The NEC provides guidelines for the spacing of conduit supports. Conduit fittings, such as couplings, connectors, and elbows, must be listed for use with the type of conduit being installed. Conduit systems must be properly grounded. The NEC specifies the requirements for grounding conduit systems. When installing conduit, it's important to follow all applicable NEC requirements. This includes proper grounding, wire connections, and conduit fill calculations. By following these requirements, you can ensure that your electrical installations are safe and compliant. Branch circuits are the circuits that supply power to individual electrical devices and appliances. The NEC specifies the requirements for branch circuits, including the types of wiring methods, overcurrent protection, and grounding. Branch circuits are typically classified according to their voltage and amperage rating. Common branch circuit ratings include 15 amp, 20 amp, and 30 amp circuits. The size of the branch circuit wiring must be appropriate for the amperage rating of the circuit. The NEC provides guidelines for selecting the correct wire size for different amperage ratings. Branch circuits must be protected by overcurrent protection devices, such as circuit breakers or fuses. The overcurrent protection device must be sized to protect the wiring from overloads and short circuits. Branch circuits must be properly grounded. The grounding conductor must be connected to the equipment grounding conductor of the branch circuit, creating a continuous grounding path back to the service panel. The NEC specifies the types of receptacles that are permitted for use on different branch circuits. Receptacles must be rated for the voltage and amperage of the branch circuit. When installing branch circuits, it's important to follow all applicable NEC requirements. This includes proper grounding, wire connections, and overcurrent protection. By following these requirements, you can ensure that your electrical installations are safe and compliant. Electrical safety is paramount when working with electrical systems. Always follow these safety precautions to prevent electrical shock and other hazards. Firstly, always de-energize the circuit before working on it. Use a voltage tester to verify that the circuit is de-energized. Secondly, wear appropriate personal protective equipment such as safety glasses, gloves, and insulated tools. Thirdly, never work on electrical systems when you are wet or standing in water. Fourthly, follow all applicable NEC requirements and local codes. Fifthly, if you are not qualified to work on electrical systems, hire a licensed electrician. Sixthly, inspect electrical equipment regularly for damage or wear. Replace any damaged equipment immediately. Seventhly, use ground fault circuit interrupters, or GFCIs, in wet locations such as bathrooms and kitchens. Eighthly, never overload electrical circuits. Ninthly, keep electrical panels and equipment clear of obstructions. And tenthly, educate yourself about electrical safety. By following these safety precautions, you can prevent electrical shock and other hazards. Always remember that electricity is dangerous and should be treated with respect. If you are not sure how to do something safely, ask a qualified electrician for help. The NEC is a comprehensive set of standards for electrical installations. It is updated every 3 years to reflect changes in technology and best practices. The NEC is adopted by many states and local jurisdictions, and it is the basis for most electrical codes in the United States. The NEC covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. It is essential for electricians and other electrical professionals to be familiar with the NEC. The NEC is a complex document, and it can be difficult to understand. However, there are many resources available to help you learn about the NEC. These resources include textbooks, training courses, and online forums. It is important to stay up to date on the latest changes to the NEC. The NEC is constantly evolving, and it is important to be aware of the latest requirements. By staying up to date on the NEC, you can ensure that your electrical installations are safe and compliant. If you have any questions about the NEC, consult with a qualified electrician or electrical inspector. They can help you understand the requirements of the NEC and ensure that your electrical installations are in compliance. Electrical installations should be inspected regularly to ensure that they are safe and compliant with the NEC. Electrical inspections are typically performed by qualified electrical inspectors who are employed by local jurisdictions. Electrical inspections can identify potential hazards such as damaged wiring, overloaded circuits, and improper grounding. Electrical inspections can also verify that electrical installations are in compliance with the NEC. If an electrical inspection reveals any deficiencies, the homeowner or building owner will be required to correct them. The electrical inspector will typically provide a written report of the inspection findings, including a list of any deficiencies that need to be corrected. It is important to correct any deficiencies as soon as possible to prevent electrical hazards. Electrical inspections are an important part of maintaining electrical safety. By having your electrical installations inspected regularly, you can ensure that they are safe and compliant with the NEC. If you are planning to make any changes to your electrical system, it is important to obtain a permit from your local jurisdiction. Electrical permits are required for most electrical work, including new installations, additions, and alterations. Electrical permits help to ensure that electrical work is performed safely and in compliance with the NEC. When you apply for an electrical permit, you will typically be required to submit a set of drawings showing the proposed electrical work. The drawings will be reviewed by an electrical inspector to ensure that the work meets the requirements of the NEC. Once the permit is approved, you can begin the electrical work. However, you will need to schedule an inspection with the electrical inspector after the work is completed. The electrical inspector will inspect the work to ensure that it was performed in accordance with the permit and the NEC. If the work passes inspection, the electrical inspector will issue a certificate of occupancy. The certificate of occupancy is proof that the electrical work is safe and compliant. Obtaining an electrical permit is an important part of ensuring electrical safety. By obtaining a permit, you can help to ensure that your electrical work is performed safely and in compliance with the NEC. Working with electricity can be dangerous. It is important to take precautions to protect yourself from electrical shock and other hazards. Always de-energize the circuit before working on it. Use a voltage tester to verify that the circuit is de-energized. Wear appropriate personal protective equipment such as safety glasses, gloves, and insulated tools. Never work on electrical systems when you are wet or standing in water. Follow all applicable NEC requirements and local codes. If you are not qualified to work on electrical systems, hire a licensed electrician. Inspect electrical equipment regularly for damage or wear. Replace any damaged equipment immediately. Use ground fault circuit interrupters in wet locations, such as bathrooms and kitchens. Never overload electrical circuits. Keep electrical panels and equipment clear of obstructions. Educate yourself about electrical safety. By following these safety precautions, you can prevent electrical shock and other hazards. Always remember that electricity is dangerous and should be treated with respect. If you're not sure how to do something safely, ask a qualified electrician for help. Electrical codes are constantly evolving to reflect changes in technology and best practices. It is important to stay up to date on the latest changes to the electrical code to ensure that your electrical installations are safe and compliant. There are many ways to stay up to date on the electrical code. You can attend training courses, read trade publications, and subscribe to online forums. You can also consult with a qualified electrician or electrical inspector. By staying up to date on the electrical code, you can ensure that your electrical installations are safe and compliant. Electrical installations should be designed to meet the needs of the occupants of the building. The electrical system should be sized to provide adequate power for all of the electrical devices and appliances that will be used in the building. The electrical system should also be designed to be safe and reliable. When designing an electrical system, it is important to consider the following factors: the size of the building, the number of occupants of the building, the types of electrical devices and appliances that will be used in the building, the location of the building, the local electrical code. By considering these factors, you can design an electrical system that meets the needs of the occupants of the building and is safe and reliable. Electrical maintenance is essential for ensuring the safety and reliability of electrical systems. Electrical systems should be inspected regularly for damage or wear. Electrical equipment should be cleaned and lubricated as needed. Electrical connections should be tightened to prevent loose connections. Electrical panels should be kept clear of obstructions. By performing regular electrical maintenance, you can prevent electrical hazards and extend the life of your electrical system. If you are not qualified to perform electrical maintenance, hire a licensed electrician. They can perform the necessary maintenance and ensure that your electrical system is safe and reliable. Common electrical problems include power outages, flickering lights, and trip circuit breakers. Power outages can be caused by a variety of factors, such as storms, equipment failures, and overloaded circuits. Flickering lights can be caused by loose connections, faulty wiring, or voltage fluctuations. Trip circuit breakers can be caused by overloads, short circuits, or ground faults. If you experience any of these electrical problems, it is important to have them investigated by a qualified electrician. They can identify the cause of the problem and make the necessary repairs. Do not attempt to repair electrical problems yourself unless you are qualified to do so. Electricity can be dangerous, and it is important to take precautions to protect yourself from electrical shock. Hiring a qualified electrician is essential for ensuring the safety and reliability of electrical systems. A qualified electrician has the knowledge and experience to perform electrical work safely and in compliance with the electrical code. When hiring an electrician, it is important to check their credentials. Make sure that they are licensed and insured. You should also ask for references from previous customers. A qualified electrician can help you with a variety of electrical tasks, such as installing new wiring, repairing existing wiring, and troubleshooting electrical problems. They can also help you to design an electrical system that meets your needs and is safe and reliable. The future of electrical technology is constantly evolving. New technologies are being developed all the time to make electrical systems more efficient, reliable, and safe. Some of the emerging trends in electrical technology include smart grids, energy storage, and renewable energy. Smart grids are electrical grids that use digital technology to improve their efficiency and reliability. Energy storage technologies, such as batteries, can be used to store electricity and release it when it is needed. Renewable energy sources, such as solar and wind power, are becoming increasingly important sources of electricity. As these technologies continue to develop, they will play an increasingly important role in the electrical industry.